oral papers this morning, and then I want to point out that there are 21 poster papers that are in the room downstairs, unfortunately broken in 2 parts, so you have to find a way from one part to the other. And then I also want to single out that tomorrow morning, in a session about the sun, though only one of those really applies to the eclipse work, but that is Brad Schaefer's interesting paper on the results from his modern Eddington experiment. So that will be the last paper in a session sometime after 11 o'clock tomorrow in Potomac 3 and 4. So I've now used my 1 minute of introductory time, and we are just starting on time with Dr. C. Alex Young of NASA's Goddard Space Flight Center on Eclipse 2017 through the eyes of NASA.
So thank you, everyone. I think most of us know why we're here, so I'm not going to go into any introductions about what happened on August 21st, 2017, but it was an amazing, amazing day. And leading up to it was also amazing. I know many of us are probably still feeling a bit of depression that it's over. I know I am. But I'm not new to the sun. I've been studying it for most of my academic career, but I'm new to eclipses. But I had the opportunity to help NASA lead its primarily education and public outreach efforts for the whole agency, which was a pretty huge undertaking. And this was something that a lot of people worked on, but I did want to start off by just mentioning my team at Goddard, who were critical for the work that we did, and I just wanted to put their names up real quick. But more importantly, this was really about partnerships. This was something that NASA had never done anything of this scale in terms of education and public outreach. And also, we've done a lot of launches, but this was something that was completely beyond our control. It was going to happen whether NASA was there or not. And we had a great relationship both within the agency, across all the centers, across the government, with academia, even private industry, and professional societies. And everyone played a critical role in making all of this come to fruition. So in terms of the online, the social media, and the broadcast presence, this was the biggest thing NASA's ever done by an order of magnitude. This was the largest event for the agency. Just to give you a few bits of information to give you some of the scale, we had almost a petabyte of data delivered on a website that was not really delivering data. It was delivering relatively small chunks of information. The website had 90 million unique views, and the broadcast was estimated that we had about 600 million viewers across the globe. Now that's not to include the fact that this was an event that 10 to 20 million people potentially saw totality, but 100 million or more across the continent saw some part of an eclipse. And these are just numbers that are mind-boggling. This is nothing like this has ever happened before. This is truly the largest solar, the most viewed solar eclipse in history. This is just to show you the scale compared to things like the TRAPPIST or the Pluto Horizons flyby. It was an order of magnitude bigger. And lastly, I wanted to mention, most of NASA's online events actually have a disproportionate amount of men versus women that view it, male versus female. And this was one of the first times where we actually had almost a 50-50 split, which was a really nice thing to see. So we did a lot of different things to support the event. We built a website. We focused around some key things, particular safety, science, citizen science, education, public engagement, as well as events. We had official viewing sites across the country we supported with materials, subject matter experts. We had 14 TV locations as well as 4 official additional web viewing locations. That culminated in a broadcast that centered in Charleston, South Carolina. We started off the coast of Oregon with an airplane. We followed the broadcast sites and ended with the International Space Station over the Atlantic. We also had unofficial viewing sites and parties and events across the country, which we tried to make available online with these Google Maps. We also had assets in space. At least we had 14 space assets. We had 3 airplanes, 55 plus high altitude balloons, as well as the ISS that all supported this event, both in the science as well as the outreach aspects. We made a lot of stuff. We produced a lot of materials for educators, for the general public. And one of the things I wanted to point out is that safety flyer, which was actually driven primarily by the AAS, in particular Rick Feinberg. That was one of the most important things that we did. And I want to bring that up again because related to glasses, so we did produce glasses which we made available for the public. And the driver behind the glasses and safety related to the glasses was, again, the AAS and especially Rick Feinberg. Dealing with the bogus glasses that were sold on Amazon, he was the key player, and he's still dealing with this today. So he really deserves extra kudos for all of the work that he's done. And lastly, we communicated with traditional media, social media, both leading up to the event and the day of the event. So I'm going to quickly go through the science. There's several great talks that are coming up. I'm not going to talk about any of the science that they're doing particular, but I just wanted to mention sort of the general picture. This was an opportunity to do a huge amount of science, not just coronal and solar physics, but also Earth and ionospheric science. This is a picture of insolation. This is the amount of solar energy reaching the ground. You can see that spot where the shadow is hitting the southeast, just to give you an idea of the impact. But this was an opportunity to basically have an incredibly well-defined cloud that allowed us to study the energy transport through the atmosphere and to better define models in a way that we could normally not do. So this was a great time to do this experiment. This is an example of the albedo from the EPIC camera. You can see the big hole. Due to the eclipse, the image is actually flipped north and south. We even had citizen science with the GLOBE project, where people measure temperature in clouds all across the continent. Using the balloons, we could even do measurements of the boundary layer, the planetary boundary layer, and show the difference between these. So this was really an amazing opportunity. And lastly, to do ionospheric science. You can see the hole in the ionosphere, and radio waves were picked up across the country, which does not normally happen in these wavelengths during the day. So this was just a fantastic opportunity, and I look forward to seeing the continued data that's going to come out of this. We'll have a few more talks after this to talk about some of the science, and there's going to be lots more to come. So thank you very much.
Question for Dr. Young?
Yes.
How do you know the percentage of women versus men?
Just in terms of recording the people viewing online, when we take demographics, and we have in certain situations, depending on the social media, I mean, it's a statistical thing, but depending on the particular social media channels, we can do demographics. So it's not exact, but the difference was vast between the normal statistics that we would get.
Another question? Yes?
You highlighted the safety emphasis that you put out with the glasses and so on. I was just curious what the upshot was for the nation. Was there significant use of bogus glasses and difficulties, or people viewing things unsafely? Any idea what the stats
Well,
are?
I mean, there was actually recently a paper that came out about a 24-year-old woman who stared at the eclipse for 30 seconds. No, was it something like 30 seconds? I don't know. She burned a hole in her retina, basically. She burned a crescent in her retina. So that's the only one I know of actually that's recorded, but lots of people had glasses that were bad, and a lot of us were scrambling at the last minute to send glasses to schools. But they were glasses where people took them outside, basically put them on, looked up, and it was painful. So it was pretty obvious that they were not good.
We're going to have some papers later from Rick Feinberg and others about this. Yes, you want to something quick?
Mention that woman who burned her retina, she was in New Jersey. She wasn't in the path of totality.
Yes, the woman with the retinal
Yes.
burn, David Dunham says was not in totality, and Rick even questioned whether she was using glasses. And I like to make the point that many people went to eye doctors worrying about themselves afterward, including people who should have been going to the eye doctor for years, and had nothing to do with the eclipse. So my claim is that there was a net gain in eye health from the eclipse, because it drove people to do routine maintenance at eye doctors. So with that, thank you very much, Dr. Young. Applause for Dr. Young. And now we